Thank you, Janet, and good morning, everybody. So I'm really glad to be presenting a few, yeah, ideas, but also achievements about standards and conventions in support of climate modeling. So I'm sure up to now you've been discussing a lot about how to use the data, and here I will focus more on the standards and convention we've been developing in the community. Of course, I won't browse all of them, but just to give you a flavor of some main ones and what's behind those standards and conventions. So a bit of context. So clearly the CMIP and Codex intercomparison projects were key drivers of convention and standards in the community. Before that, it was a bit of everybody had their own ways of doing things, and having those common intercomparison projects really helped. So this emergence of conventions and standards is always a challenge because it means often culture shifts. What we noticed, for example, when I first arrived in this community many years ago, my research work was to couple ocean and atmosphere numerical models. And I realized soon that I was also coupling cultures and communities which had different units. The freshwater flux at the ocean-earth interface was seen very differently from ocean or atmosphere experts, but also in the ways of describing variables, their physical meanings. So going to convention is always hard. So we have to keep that in mind. Sometimes I wonder why things are not yet standards and convention, because it's hard. And I'll come back to that. So I was saying maybe in terms of vocabulary, we talk about convention and standards. Standards usually are established by wide international bodies. For example, physical, what is a kilogram, and those kind of things. So convention is maybe a more community centered way of doing things together. So even though they can be used one for the other, I think it's really the scope. A convention may become a standard. So let's put it this way. So there are other subtleties for those words, but I think for the sake of this presentation, that's to keep that in mind. There's also tension between curiosity-driven activity of the research community and operations, and the level of convention and standard is clearly not the same between the two. The second one wanting more routine and interoperability, so conventions and standards are essential, whereas curiosity-driven will go to standards and convention even if forced or absolutely needed to continue this research. So there's that tension as well. Right. So STEMIP, as I was saying, and Codex were both quite instrumental in driving standards. So what STEMIP is just a couple model intercomparison project. I'm sure you all know. You seem to have a quite good knowledge, all of you, of this. I won't spend too much time. Just to say that the goal was to address a number of scientific questions through common experiments, and you see here a number of those experiments, so which we call them MIPS, intercomparison projects, looking at different aspects. For example, the specific role of ocean, or a paleo setup, or the chemistry, or looking at the carbon cycle, or decadal predictions, and some maybe more to look at variability, predictability, future scenarios, like those at the bottom here. Some maybe response to forcing, and then systematic biases. So these MIPS are clearly made in support of IPCC reports, and to be able to have 20, now it's close to 70 models be compared together, standards and convention were absolutely essential. And just to give you an overview of the infrastructure that goes around CMIP is all the links between those. So typically there are, when we do the CMIP, there are specifications, the type of data that will be requested, model outputs, and then there are some control vocabularies, as we call them, CVs. The CF convention will come back to it. Then the models create this output as netcdf files. It's archived in ESGF, which you probably already heard of. And then there are a number of services that will go to either search the database, create errata services, provide IDs, citation services, and then documentation. So for all these arrows to work and interoperable, we need standards, clearly. And a lot of work of the community in the last 10, 15 years has been to work on those standards. And of course, the standard is a service of a goal. So the CMIP enterprise was clearly the strong driver. So just to give you an example, for example, that CF convention here, and basically the CF, so CF has a long history. It stands for climate and forecast, the two letters. And there's a website where you can find more details about this. But so clearly these conventions are there to promote the creation, processing, and sharing of this data, both observed and forecasting. So using netcdf files, although the physical format of the file is not necessarily fixed, there were a time where SGF format files, I don't know if these words speak to you, now SGF has been incorporated into netcdf. There's a whole history of those physical file formats, but it's really about the convention. So an important part of the CF convention are the variables, the CF variables, and which to define rules for the variable attributes. For example, a unit, on what grid it is set up. For example, on the right-hand side here, you show the elements of CF that describe the domain. So all what is needed to describe the grid of the data. And you see it's quite complex. So here, typically, and that's a lot of work the community is doing, is to work on the concepts before looking at how to implement the concepts. So these type of diagrams are called UML. So it's a universal markup language. It's just a way of putting the concepts together and seeing what are the relation between those concepts. I won't go into details, but the concept of domain, it needs some ancillary fields. It's attached to a field that is going to need it. There's a cell methods, how the grid was constructed. There are some axes, etc. So all these are relationship, and the CF convention is to expose those and agree on those links. So the goal is really to identify variable in a sufficient way so that data from different sources can be distinguished and decide which one are comparable. A temperature has different meanings in different contexts, so the need to define it precisely came, of course, very early. And of course, the CF standard names are there for that. And it's really this idea of clearly identifying the data so that when it's used for the right purpose. So the goal of CF is to provide a definitive description of what data physically represents, not just the description of relocation, which is important, but it's beyond that. So currently there are over 4,000 standard names, and you can find them on the website or in different tables. For example, here air pressure this is the name, there's the description, and there's the canonical unit. So this is an example of a standard name, and it's a lot of work that went into these to define all those. So that's about the CF standard, which is really key in our community. Another example of standard is the model and experiment documentation for CMIP. So if you go on the ESGF, which is that bottom right exploration tool here, maybe some of you already went there when you're looking for CMIP data, model data. So you search and you end up with those units of search. So this is a blow up here. You see a name of a file, and it will tell you where to find it, a version, and then you have a number of services here are links. So you can list the files, you can get scripts to get the data, show the citation and ID, but you can also what we call the further info. And when you click on this, it leads you to a service that is provided by IS-ENES through ESDoc. So this service actually is also available in every, as an attribute in the NetCDF file, which is that further info URL, which is a unique attribute to every file. So it has that name here. So basically, it will tell you what MIP era you're in, the institution, the model, the experiment, ensemble description, machine performance, a number of data sets that are here to fully document how the simulation was made, what is the model, how the model is described. So you see here on the right-hand side, those different elements of information, the project design, so the CNIT, the experiment, who did it, what papers are referenced, the model setup, how it conforms to the protocol defined by the project and the experiments, some more technical links on what machine was run, what was the performance of it. Here it's not the scientific performance, but the technical performance, how fast it was running, etc. And then for the ESGF publication, the ensemble description, how the ensemble was made, if there are 10 simulations, what are the differences, the simulation was run, and the different members as part of this ensemble. So again, to do this, if you're looking under the hood, there's a lot of standardization and conventions to be able for all this system to seamlessly work between all these different services I was showing earlier. Another important thing, which is probably of interest to you as end users, is the errata service. For a database that is several petabytes, it's inevitable that there are some problems with the data. So now we have a system that everybody can flag that this data may have a problem, and then the groups will answer saying, well, we don't think it's a problem, maybe it's a problem on your hand, or they say, yes, it's a problem, we will either not correct it, or we will correct it, and here it is, it's been corrected. So following this is really important, and that's that errata is an important also service. It completely builds on those standards. Right, so I will just conclude with a few points. So CMIP was key for developing standards. As I was saying, it's really important to keep that in mind. Also, when your community will work on standards and convention, we have to take into account what I call the resistance. So the resistance can be for maybe not good reasons like inertia, resistance, ignorance, competing standards, lack of resources, legal barrier, etc. But also sometimes it's for good reasons. When science is being developed, and for example, in the model documentation, when we're developing a standard way of describing an atmospheric convection, there are parts that we cannot standardize because the research is still being done. So we have to keep this aspect a bit open and not having standards or convention. So finding this fine line is part of the job of helping the community towards those standards. Clearly, building trust is not easy. For example, if we take the NetCDF CF, it took years for the modeling groups to take that into account. For years, they had to develop tools that would translate their own standards and file into the NetCDF CF. And now, I think a large fraction of the groups invested a lot of effort so that their models directly produce the NetCDF with the CF convention. And they had to trust this was to become the standard before they would invest a lot to modify their huge codes towards that. And I was saying, yeah, blue sky research needs space, and convention can come in a second stage. A new context, which is a fair context about data, which is to find, access, interpret, and reuse the data, is providing an important framework to develop those standards around the data we produce. And so these are made both at the EU level, but also internationally. I also want to say that climate modeling community, which goes from very basics, physics, all the way to impact studies and social studies, economics, etc., is a hugely diverse community. What I've seen over the years, which was really interesting, is that when you start collaborating, this helps creating convention, and vice versa. When you start having convention, you have a common tool and helps you collaborate, or not. It's not always a common tool, but a common way of discussing with each other. So this interaction is really important in support of the whole, climate change and climate enterprise for the research. And also, I want to stress the importance and the role of end users, and a number of you are, in driving conventions. A lot of clearly creating a conventional standard for within the climate modeling community is different than taking into account the needs of the community, of the end users in developing conventional standards. So I think basically all this workshop that Janet is organizing and the others are for us a way to gather requirements that will help us drive and develop new conventions in support of climate modeling. So you had a presentation about the ESM-VAL tool and model evaluation, and I wanted to finish on what we're currently working on in the next steps of convention, which is model evaluation. So just to talk about the different stakeholders between the climate information user, which would be end user, or climate experts and software and data engineers, and they all have different workflows. The climate information users define a science question. They're going to choose some metrics, some way of evaluating the models, choose the models they want to apply to, run and view the metric, analyze the results, and maybe come back to refine the question, etc. The climate experts, they may be able to define the metrics as a function of the science question, because there's no absolute metric. It depends on what the question is. I call a metric a distance between the model and some reference, which is observations or analysis. They may be able to program the metric. They will do the science update of the metric as new science is understood, new observations come in, etc. There's some update needed. And of course, the software and data engineers, they build the software to run the metric, to view the metric, and they do the IT update. And certainly accessing a huge database is essential. So for these three type of actors to work together, there needs to be interfaces, and interfaces means also standards. There's one which is the science question interface. So climate information users and climate experts need to discuss together, to define, understand each other's perspective and points. So there needs to be that place. Of course, we need users interfaces so that the users are able to run and view the metric using the software. And there's that science IT interface, which we're working on in IS-ENES3. The idea would be, for example, that any group of climate experts can develop a package. We're developing one on ENSO, for example, El Nino, and that package would fit into the software, for example, ESM-VAL tool or the large software infrastructure in a standard way, because there would be a standard science IT interface. So these are the things we're working on, and the idea is really, all these standards and interfaces are there to articulate different actors, different expertise and expectation. It's important that when we scale up and this huge enterprise is made in a way that it can be modularized and people can work on what they're good at. And so hence the importance of standards and conventions. And I'll stop here.